Radio wave propagation. యాక్చువల్గా రేడియో వేవ్ ప్రాపగేషన్ ఏంటంటే ఫస్ట్ మార్కోని అనే ఆయన సైంటిస్ట్ ఇన్ ది ఇయర్ 1895 లాంగ్ డిస్టెన్స్ కమ్యూనికేషన్లో ఈ వేవ్ అనేది ఆయన ఫస్ట్ ఆయన ఇన్స్టాల్ చేశారు. ఫస్ట్ లేటర్ ఏంటంటే వైర్లెస్ ట్రాన్స్మిషన్ ఇటలీలో ఇన్స్టాల్ చేశారు. ఓకే, ఫస్ట్ వన్ ఏంటంటే రేడియో కమ్యూనికేషన్ తెలుసుకుందాం. నథింగ్ బట్ ఏంటంటే రేడియో వేవ్స్ ఆర్ ఎలక్ట్రోమాగ్నెటిక్ వేవ్స్ that travel in a straight line. It is also known as a traveling wave అని కూడా పిలుస్తాం. ఓకే, రేడియో వేవ్స్ అనేవి మనకేంటే బేసిక్గా 3 టైప్స్: గ్రౌండ్ వేవ్స్, స్పేస్ వేవ్స్, స్కై వేవ్స్. యాక్చువల్గా గ్రౌండ్ వేవ్స్కి ఇంకో పేరు ఉంది, సర్ఫేస్ వేవ్. స్పేస్ వేవ్కి ఇంకో పేరు ఉంది, ట్రోపోస్ఫెరిక్ వేవ్. ఇదేంటంటే స్కై వేవ్ ఏంటంటే అయోనోస్ఫియర్ వేవ్. ఇన్ దిస్ ద ఎలక్ట్రోమాగ్నెటిక్ వేవ్స్ ఆర్ యూస్డ్ టు ట్రావెల్ నియర్ ది సర్ఫేస్ ఆఫ్ ది ఎర్త్. It's having low frequency so that it may be used in VLF, LF and another one is MF. That is very low frequency. Low frequency, another one is medium frequency. Whereas tropospheric, it is used to space at 16 kilometers above the earth's surface. In this, the electromagnetic waves is simply transfer from transmitter to receiver. Okay, it mainly used in FM, TV or radio. It's having a frequency up to 30 megahertz frequency. It is used to support. Okay, another one is ionosphere. It is known as high frequency. Nothing but it's used to support the frequency ranges from 2 to 30 megahertz clock frequency, as well as it's placed between 60 to up to 450 kilometers above the earth's surface. Okay, it simply transfers the wave into space and reflected back to the earth's surface. Okay, these are about ground, space. Another one is sky. Next one, I go for line of sight. What is meant by line of sight? Line of sight propagation. Every wave is used to support and is used to suffer propagation of a wave is used to depend upon line of sight. Nothing but it is used to transfer from first antenna to second antenna. The wave will transfer from transmitter to receiver. Okay, for that, in this the waves are transmitted from transmitter to receiver so that it may be travel from rocks, rivers or lakes or walls, so that the waves suffer the line of sight. In this, we are using mainly VLF, HF, UHF and microwaves links to transmit the wave. It mainly is a line of sight is mainly depend upon attenuation. Okay, another one is in this the line of sight may be are of 2 types: optical line of sight or effective radio link. Both can be derived by using distance d. D is equal to nothing but d value nothing but k nothing but 3.75 root of h, another one is 3.75 root of hk. Okay, nothing but d is, it is the distance between antenna and horizon, whereas h is height of antenna. Okay, right, whereas k means nothing but it is approximately a constant, it acts as a simply constant. Another one is maximum distance that the two antennas can be derived as by using the below formula depend on line of sight, that is nothing but 3.75 root of kh1 plus root of kh2, where h1 is height of antenna for first antenna, where h2 is antenna for second antenna. This is the nothing but line of sight. Okay, another one is tropospheric. In this we briefly studied about tropospheric, nothing but skyway, nothing but tropospheric layer wave. It mainly placed at from the earth to at height of atmosphere. It's mainly, that is approximately 7 miles from the earth's surface. It mainly used to study about weather phenomena. In this, the air is in constant motion. The motion means turbulence. Okay, turbulence may be suffered depend on reflection of the or refractive index. Refractive index can be explained by using dispersion, and I mean refractive index must be explained by using scattering. Scattering may be nothing but tropospheric scattering. It is nothing but it is used to derive the weather phenomena. It mainly depend upon two factors. First one is atmosphere, another one is pressure. Depending on these two characteristics, the weather position may be changed. The weather position can be traced out by using troposphere. In this, the scattering maybe it's having frequency from 100 megahertz to 10 gigahertz, whereas troposphere scattering is used to cover from 5 miles to roughly approximately 500 miles also. That is the tropospheric advances. Whereas in this, the wavelength as well as frequency are both are inversely proportional. That is about tropospheric wave. Another one is tropospheric. Another one is these waves are used to support and used to depend upon polarizations. Nothing but in this the wave, what is meant by polarization, used to check. That is polarization. Polarization means nothing but the wave that is used to determine the oscillations, how the wave did propagate in terms of electrical field. In this, there are having two types: horizontally polarized, another one is vertically polarized. Okay, what is meant by horizontally polarized means, in this the wave propagates, that is parallel to earth surface, whereas in but it is the wave propagates that is perpendicular to earth surface. Okay, this is horizontal as well as vertical. Another one is used to study about ground, another one is space, another one is sky. Okay, this in ground waves, it is used to support in the earth is a perfect good conductor. it's in this horizontally polarized are not allowed, whereas in space, in this the waves are elliptically polarized. It is used either horizontally or vertically polarized, or both are allowed, whereas in sky wave it is unstable in nature. Horizontally polarized or not, you it may be allowed both. It may be either vertical or horizontally polarized, both are. That is just about sky waves. Another one is these waves are mainly depend upon two fact. Most of the important factor that is known as attenuation. What is meant by attenuation? It is used to check attenuation. Attenuation means the signal the used to suffer attenuation. That is nothing but the signal has been reduced because of walls, rocks, or well as lakes, etc. The attenuation can be derived in terms of decibels, nothing but dB. A dB is nothing but it is a natural logarithm of power relation, 20 natural logarithm of power relation, that is P2 by P1. Another one is, whereas in metal, the metal wall, nothing but it's having decibels up to 6 dB, whereas in office window it's having the decibels of 3 dB. Like that, in plaster board it's having a decibel up to 3 dB, whereas in glass with metal it is used to suffer another 6 dB. Nothing but attenuation, it is used the signal strength been reduced. Okay, entire propagation can be done by using two antennas like this. It has nothing but the signal transmit from this end to this end. This is nothing but transmitter. Another one is receiver. This is the basic idea on radio wave propagation.